A single mouse click on this screen costs $75. To teach an artificial intelligence how to find a microscopic shadow in a lung, an elite medical specialist must sit in a dark room, manually drawing a precise yellow box around that shadow. Now multiply that click by 10 million. This is the hidden, grinding engine of modern technology. We were told AI would free us from tedious labor, but the reality is the exact opposite. AI has become a digital beast that must be hand-fed, bite by bite, by the most expensive minds on Earth. Under the old paradigm, known as supervised learning, we treated AI like an intern who needs their hand held through every single task. If you wanted a model to spot a bone fracture, a skin lesion, and a brain hemorrhage, you had to build 3 separate, massive pipelines. This is the operational nightmare known as MLHOps. In the early 2020s, hospitals and tech firms poured billions into these custom systems, only to watch them fall apart the moment they encountered real-world data. Why? Because medical data is messy. Scans from a different machine or a slightly different angle would cause the models to fail completely. The human hand-holding did not make the systems smarter. It made them incredibly brittle. By 2024, the tech industry faced a hard truth. We had completely run out of human hours to label the data required to build truly intelligent machines. The human bottleneck had stalled the future. There is a common belief that the breakthrough in modern AI happened because we finally created perfect, clean encyclopedias for these systems to read. We imagine teams of engineers carefully sorting the sum of human knowledge into neat, labeled folders before feeding it to a supercomputer. But that is where everyone is wrong. Curating a perfect dataset is not just difficult, it is mathematically impossible. When you clean a dataset to make it perfect for a machine, you strip away the chaos, the noise, and the weird edge cases of the real world. You are training a driver on an empty track on a sunny day. The moment that model enters a real-world hospital or a real-world street, it panics. The actual breakthrough did not come from making datasets cleaner or more organized. It came when we stopped trying to organize them at all and decided to let the machine drown in the raw, messy, unlabeled chaos of reality. The breakthrough is a concept called self-supervised learning. It sounds like academic jargon, but it represents the most radical shift in computer science in 30 years. Instead of a human teacher pointing at a dog and saying, "That is a dog," the AI becomes its own silent teacher. It does this by playing a continuous game of hide and seek with itself. Imagine giving a machine 100 million unlabeled clinical notes and medical scans. No labels, no descriptions, no human guidance. The machine looks at these files and begins to hide parts of them from its own neural network. It might block out a word in a sentence or blur out a section of an X-ray. It then forces itself to predict what was hidden, based entirely on the surrounding context. By doing this billions of times, the machine does not just memorize what a tumor looks like. It learns the underlying grammar of the human body and the natural laws of medical language. To understand how this works, imagine you are handed an ancient, damaged manuscript with half its words smudged and unreadable. You have never seen this book before, but you understand how language works, how nouns follow verbs, and how historical stories flow. By studying the legible text around each smudge, you can easily guess what the missing words must be. If the text reads, "The knight drew his brand new blank and rode into battle," your mind instantly fills in the blank with sword. You did not need a teacher to tell you that. You used your structural understanding of the world. Self-supervised learning does exactly this with billions of images and texts. By constantly reconstructing these missing pieces, the AI builds an internal map of how things relate to one another. It learns that a certain pattern of shadows on an X-ray always co-occurs with words like pneumonia or fluid buildup. It discovers the laws of the world by trying to repair its own broken version of it. We are now seeing the real-world proof of this shift. In the past, if you wanted an AI to understand medical images and clinical text together, you had to spend years building custom, hand-labeled datasets. But in 2025, researchers released MedGemma 1.5, a family of medical foundation models. These models were not trained on a massive mountain of manually labeled medical cases. Instead, they were pre-trained on vast, raw, multimodal datasets containing millions of unlabeled images and texts. Because the model had already spent billions of steps predicting hidden parts of these raw files, it developed an advanced, intuitive sense of medical reasoning. When researchers tested it on complex clinical tasks, they found something shocking. The model required only a tiny fraction of the human annotated data previously needed to achieve expert-level diagnostic accuracy. It did not need us to hold its hand anymore. The silent teacher had already taught itself the basics of medicine. But this shift from human labeling to self-supervision is not a free lunch. We have traded one massive bottleneck for another. In the old days, the cost of AI was human labor, the armies of workers labeling data. Today, the cost is raw, unadulterated energy, and computing power. To let a model teach itself by guessing missing pixels and words billions of times requires massive server farms running at scorching temperatures for months on end. There is also a deeper, more troubling trade-off: evaluation. When a human labels a dataset, we know exactly what the AI is being taught. But when an AI teaches itself on raw, unlabeled data, we lose that visibility. We are left with a system that performs brilliantly, but we do not fully understand how it arrived at its internal rules. If the raw data it learned from contains subtle, systemic biases, the model will quietly absorb those biases as universal truths. We have created a student that is incredibly smart, but whose study habits are entirely hidden from us. For decades, we tried to build artificial intelligence the way we build traditional software, by writing strict rules and forcing the machine to memorize them. We treated machines like students who could only learn by rote memorization from a textbook we wrote for them. But the real world is too complex, too unpredictable, and too vast to ever fit into a textbook. By stepping back and letting machines learn from unlabeled data, we have finally aligned technology with the way human beings actually learn. A child does not learn to walk because someone explained the physics of gravity to them. They learn by falling, adjusting, observing, and silently building their own map of reality. The era of the human crutch is ending. As we move forward, the most powerful systems on Earth will not be the ones we taught most carefully. They will be the ones that listened most closely to the silent teachers of our world.